everyone, and welcome to section 11.2. Even though I'm not here, I'm currently going to be in Green Lake, Wisconsin, again attending the Wisconsin Mathematics Council. So today's learning target is going to be recognizing whether an equation, and the equation is going to be in conic form, and whether this conic equation is going to be a parabola, a circle, a hyperbola, or an ellipse. And so that's what we're going to be talking about today. So it should be an easy topic. Again, we're going to go back to parabolas when I come back on Monday. So first of all, we talked about with the various pictures, I was showing you how that there's three types of conics. We can have the hyperbola, the ellipse, and the parabola. And so the circle is considered the fourth. And again, the reason the circle and the ellipse happen, it's because you have an intersection between a cone and a plane, and where it's going to be a closed curve. The circle is going to happen when you're cutting the plane is parallel to the plane of the generating circle of the cone. And so that's why it's generating that. If we have a cutting plane, if it's parallel to exactly one line of the cone, then the conic is going to be a little bit unbounded, and so we call that a parabola. And then in the other case, we're going to have a hyperbola. So again, if the plane intersects both halves of the cone, it's making two separate unbounded curves. And so, however, though, sometimes we, again, will ignore that. So if you kind of take a look at graphic 1, that's showing you again that is that lovely parabola example. And then number 2 is trying to show you a little bit of a circle and showing you the ellipse, depending on what the angle it's going at. And then picture 3 is trying to show you the hyperbola, how it's cutting both parts of the plane. And so that's what's making that difference. So this is the big equation and the big stuff I would like you to know for today. So, and we're going to use this throughout this chapter. So we can define a conic algebraically in terms of this second degree equation. So we have ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. You're like, oh my God, that's a pretty big equation. It's really not too super horrible, because really what we only really need to focus on is what's in the A position and what's in the C position. So the rest of it, we don't care. And so we just want to make sure again that it's going to be equal to 0. So we want that to happen. And we want to be able to look at where that A letter is, which is going to be front of the x squared term. And then we need to know what is C, which is going to be what's in front of the y squared term, if there is one. And so we have 4 situations that will occur. And by knowing these, we can see what kind of conic it would be. So again, this is a very, very simple, basic kind of lesson. So first of all, we can figure out if A times C, if that's equal to 0, that means I'm either missing the x squared or I'm missing the y squared. Somehow when I multiply them, I'm going to get 0. For the circle, that's when my A value and my C value, which is the numbers in front of the x squared and the y squared, that they're the same number. And so if they're the same number, that tells me that my conic is a circle. Next, we have an ellipse. An ellipse is when I get some kind of number for A and a different kind of number for C, and in such a way that I multiply them and I get a positive number. So that's what it means by being greater than 0. So it's going to be a positive number, so therefore that's going to make what we call an ellipse. And then finally for hyperbolas, again, that's also resulting with our A times our C value. It's just that the difference is that we're going to get a negative answer, and so that means again that it's going to be less than 0. So that tells me that my answer is a hyperbola. So again, I want you to be able to look at an equation, figure out what is the A value, what is the C value, figure out what out of these 4 cases we're looking for, and then just name it. And we're not going to do anything else other than that. Okay, let's take a look at example number 1. So in example number 1, what we have here is we're going to look for the number in front of the x squared. In number 1, there is not an x squared. So therefore, that tells me my A value is going to be 0. And then I do have a C value. That's the number in front of the y squared. So my C value is 4. And so now they know number 1. They're not going to be equal to each other, so I know this is in a circle. So the next situation, since they're not equal, we're going to multiply them. So we're going to figure out what is 0 times 4. And so what will we get? Will we get 0? Will we get a positive number? Or will we get a negative number? And so hopefully you'll know 0 times 4 is 0, which basically tells me since it's equal to 0, I have a parabola. Because my A value is 0, my C value is 4, therefore again it equals 0, so it's a parabola. Okay, let's take a look at the second example. So this is all what I want you to do for each problem. You know, write down your A value, write down your C value, figure out what case it is, write the name of the shape. Super easy. So for number 2, we have x squared minus 4y squared plus 2x plus 8y minus 7 equals 0. That equals 0 is very important. And so therefore we're going to have the A, the number in front of my x squared is a 1. So I'm going to write that down. My C, that's the number in front of my y squared, which is going to be negative 4. So first of all, A and C are not the same. So it is not a circle. So let's multiply them. So 1 times negative 4, and we'll have to figure out, well, what does that equal? Well, that's going to equal negative 4. And so since it's negative, that's telling me that it's smaller than 0. So this has to be a hyperbola. So when I get a negative number when I'm multiplying A times C, that's this hitting this case. So that's how I know that. So the first answer, parabola. Second answer, hyperbola. Okay, 3, 4, 5, and 6 are kind of jam-packed together, but we'll be okay. So I'm just going to put my work a little bit separate. So for number 3, we have the number in the A expression. Again, is 3. Again, just look for the x squared and the y squared. So the A value is 3. The C value is also 3. Wait a minute. If 3 and 3, they're equal. So if A is equal to C, then we have a circle. And we do, because 3 is equal to 3. Okay? Number 4, we've got ax squared plus 25y squared minus 54x minus 50y minus 119. So again, the number in the A position is 9. The number in the C position is 25. So notice they're both positive. They're not equal. So that means we're going to multiply. You always multiply them unless they're the same, because then they're a circle. So this I can multiply. This is going to give me a positive number. So when we think about that, I mean, that's going to work out. So I'm going to end up, you know, with 225. And so 225 is definitely greater than 0. So that tells me that since it's greater than 0, this is an ellipse. Because, again, if I'm dealing with that situation, that's what we'll get. Number 5, notice we have an A term of 1, no C term. There's no y squared in number 5, nothing. So therefore, we're just going to, again, they're not equal, so it's not a circle. And then we're going to multiply that. Notice we'll get 0. And so anytime that A times C is equal to 0, that's a parabola. So anytime I give you a conic equation, that's what I want you to do. I want you to kind of look at it, and eventually we'll learn each different conic at a different pace. But then just make sure that when we put them all together, when we review at the end, you know, that's how I want you to be thinking when you first are trying to identify what shape it is. Okay, number 6. We're going to have 25x squared. So that will be my A value. And then we look for the y squared. That's a 2. And they're not the same, so it's not a circle. So I'm going to multiply them. Now if I multiply them, I'm going to get 50. 50 is a positive number, so this is going to be just like number 4. This is going to be an ellipse. Okay, finally, our last 4. So for our last 4, be careful. Signs are important, and so don't ever think that they're not, because in algebra, it's super duper important. So in number 7, my A value is going to be 3. and my C value is going to be negative 3. So this is not a circle. Even though it's the same number, which is 3, we have different signs. And so when we have that situation, then we have to do the multiplying case. So we're going to have 3 times negative 3, which again is going to give me negative 9. But negative 9 is less than 0. So since it's less than 0, this is a hyperbola. So anytime I get a negative value, it's a hyperbola. If we take a look at number 8, the A value is 3. The B value, probably not B, C value is 2. And multiply them. They're not the same number, so we're going to multiply them. We're going to get 6. 6 is a positive number. It's greater than 0. So therefore, this is an ellipse. Number 9, no x squared. So the A value, 0. B value, or probably C value, I always sometimes can mix myself up with B and C. This is a C value. So C value is 1. And again, they're not the same, so it's not a circle. Multiply it. I'm going to get 0. So remember, when it's equal to 0, it's a parabola. And finally, for our last example, A is going to be 1. And then we're going to have C being negative 3. Again, they're not equal, so it's not a circle. So we're going to multiply them. We're going to get negative 3. And we know that negative 3 is less than 0. So this is a hyperbola. So hopefully by looking at all these different examples, you can see now how we can identify which conic it is going to be. And so that is concluding this particular podcast. Make sure on the top of your worksheet, I would write this equation if you need it. Otherwise, what would be another good thing is to write the different scenarios, the 4 different scenarios that I'm talking about right here. You might want to write those on top of your sheet. Or again, you can refer to your notes. All right? And as always, have a great day, guys.